After years of learning, you finally decided to build a machine learning project. Okay. Now, you think of a project which is in your mind. You go on Kaggle, you search for the project, you get similar results or related results. Then you get a data set and you directly go to your Jupyter notebook to build the project. Okay. Now you did some data analysis. Now you fitted the model, you check the score, and you predict the new unseen data. And wait, you get a really good score, and which is a very good sign for your project. And you did really great job, and you're really happy, you're really cheerful that you have actually made a sensible thing, okay, which is actually real practical thing, okay, and you're done with the machine learning project, okay. Now, do you really think is it a project? Like, rewind 1 minute of your life and think, is it really a project, or is it just 4 or 5 lines of code which is just nothing compared to the actual machine learning project? Do you really think it is a project? Really? No, obviously it is not. So machine learning is not what we see. It is not even we think. Okay, it is not something we can even think of. Yeah, we can definitely, but not in a way it should be. Okay. Now, here, what I want to tell you, what I'm going to tell you is that how a machine learning project is done. It is done actually mostly in the industries and in the high level of code in the companies and the upper level of game, okay, in the upper atmosphere of the machine learning. Okay, if it is atmosphere, then the upper atmosphere of machine learning, what it is and what it is not. Okay, so let's get started. The number one thing which starts with is problem. Why machine learning? What are we dealing with? Why machine learning? What is it solving? Okay, now suppose you work in a company. Okay, you work in a company and you tackle a project, you tackle a problem every day. Okay, either it is of users, either it is of system, or either it is of something, a particular problem that you face every day. Now you think of using something that can solve it, and you come with a solution, and it says machine learning. Machine learning is the way which can help you. Okay, now you think as an engineer who is actually working. Okay, you do not think as that it will predict very well, it will generalize very well, it will have a good metric score, or whatever it is shown. But you think of as a someone as a person who has a business mind, because what you're doing actually there is that you're helping the business to grow or to reach to the a lot of people, to the more people. Okay, now you think of ML as a business, and you think that if I solve it, if the problem, the machine learning, if I solve the machine problem with the machine learning, will it increase will it increase the profits of the company, or will it decrease its losses? Okay, if the company is making profits, then you can add more profit to it, or if the company losing money in a some area, then you can reduce the losses. You cannot actually recover, but you can actually reduce the losses. So you think of that, and you really come with the you come with a conclusion that it will actually increase the profit, okay, or it can decrease the losses. It's totally upon the how complex the problem is, okay, and you actually go for building a project. Now, this is the most important thing, is that it doesn't matter that how well your model generalizes, how well your model is performing or on the unseen data. It matters, but what really matters, that is it providing a business, is it providing value to the business or not? If it doesn't, then it really doesn't matter how good your model is. If it providing the value in any way, okay, that is really well. Okay, that is the thing. Now you build a project. Okay, now we do not have to think it as a project, but as a product. Okay, we have to think it of think of it as a product that will actually help the people, okay, help the business or any service or any client or whatever it is. But we have to think or build it as a product, not as a project. Okay, so this is the thing we have to keep in mind. Now we want to build the model. Now the first thing that we need is the data. The very single most important thing in the machine learning is data, because without data there is no machine or learning. Okay, now we try to get the data and we go on Kaggle. No, not really, that we will not get the data. Okay, so we want the data which has actually value, which has actually the real uh, life scenarios, okay, which has actually the insight that we want to build the project. Now we want real-time data. We want real-time data and we go for the APIs, okay, that is provided, and the data that is public or whatever if we get from a source. Okay, now we have raw data. We will clean the data, okay, because there are a lot of noises in it and we want to clean it. Now we want to get the every single insight in the data, what pattern it has, what are the things it is, its distribution, and its value, what it has, what is want to say, what kind of data it is, and what does it really want to get tackled with, whether it's a supervised problem or whether it's a unsupervised problem. Our strategy will be according to the project, the product or the project. Okay, will for it will be from the data. Okay, now we got all the insights. Okay, now we go for the data analysis. We like deal with the data and we get all the thing listed what we want. For the every column, every row, we do as we want, whatever we want. Now we want to represent the data. We need to represent the data because we have to feed the data in the perfect form for the machine learning model. Okay, we cannot just put the data as we got it. We have to make it in a way that it is accepted by the model. Okay, so we have to represent the data. Then we have to move to feature engineering, in which that we build or make new features out of the same data, okay, as needed. Then we go for the feature selection because there are a lot of data in it, because we're not talking about 10 or 20,000 of data, we're talking about millions of samples in it, okay, which is like very large data set, and it has a lot of rows and columns, and the features that we have will be some useful and some not very useful. Okay, some will be mid and some will be very efficient. Okay, so we want to actually select the data feature which is actually important, okay, which we think it is important or it should be according to the problem. Now feature extraction, getting the feature which is actually very important, okay, because sometimes we think the feature is very important but it doesn't. Okay, now feature relation, how it is related to the each feature, okay, because there should be a pattern that is recognizable so that we can perform machine learning in it. Okay, now the pre-processing of the data, and we have to find which kind of pre-processing data it is. Like pre-processing, think of it as a like making the data in the same way as of all, because uh, all the samples of the data will not be in the same manner. Okay, so we want to make it in the same manner, so it is helpful and is helpful and the some scenarios and not helpful in the some scenarios. Okay, so we will need to do everything and we'll figure out what is important at the end. Okay, now we come to the splitting, and most of the people will think of splitting as that we have to split in like train and test data set, and with that using train okay, using that train data training data, we train the model, and using the test data we evaluate the model. Okay, but there is actually a third data set also, which is validation data set. Okay, now using the trained data set we train the model, and using the valid data set we select the model. We use hyperparameters to check the best uh, best combination of hyperparameters to get the best result. And then we have the test data set, which is actually used for evaluation of the model. Okay, this is, and we have this also. But wait, sometimes we could be lucky and we could be unlucky. Okay, sometimes we will have a lot of similar data to the train, and there will be a some group of data which is like totally different, which is not even seen in the training set, in the test set. Then our model will perform very poorly, like very poorly, because it hasn't been trained with the data which it will tackle. Okay, with the unseen data, then it will not be a good thing. Like suppose of a thing, uh, and then the train and testing, training and testing some, suppose that this is our the sorry, this is not the good way. Yeah, think of it as a training data, and this is office. Okay, test data. So there will be some data which will be here, which is a kind of a data. Okay, and here we'll have very different data which is not even seen by this model, and which is not even similar with this model. Sorry, with this, not even similar to this data. So which will cause our model to perform very poorly. Okay, then we come up with a lot of uh, new ways to actually tackle this problem, like cross validation. Okay, like cross validation. Okay, which uses the data set, like it uses the same data set but with different splits. Okay, it uses a data set but with different splits to get each and every sample of it to get trained and tested as well. Okay, so there are a lot of things that I can tell about cross validation, but it is not about explaining every topic, but it is about how is it done. Okay, we use cross validation, and there are a lot of even things in the cross validation also. Okay, there are a lot of things in the cross validation also. Okay, so in the cross validation, the types of cross validation are k-fold, okay, stratified and LLOCV. Yeah, means leave one out cross validation. Okay, these are the type of cross validations. Okay, now after doing all this, we splitted the data. Okay, we did everything. Now it is the time to actually go and select the model, train our machine learning project. Okay, the data in it. Now we go for algorithm. So according to our project requirement, if it is supervised, then it will be either classification or regression. Okay, or if it is unsupervised, it could be clustering, sorry, DB scan. Okay, it could be association. Okay, whatever it is. Okay, whatever it is. So suppose if it is a supervised problem, so, and if it's supervised, then we'll use the algorithm which is requires. Okay, whether of classification or regression, we go and we use the algorithm. But wait, it is not that easy, because we are dealing with very large data, so we cannot just use any algorithm to it to just check, because the training of it will be very expensive, and expensive in a way that it will be computationally expensive. Okay, so we have to think of every aspect, whether it is computationally expensive, whether it is time expensive, is it feasible or not, because we are talking about here models. We need large computers, we need large memory. Okay, we need very large spaces or large what you could say large resources to train the model. So it costs dollar to dollar. Okay, every training costs dollar to dollar to train the model. Okay, is it feasible or not? Okay, or or okay, is it computationally expensive? Is it feasible or not according to the model, or it needs a lot of uh, RAM or any other resources to train the model? Okay, we have to think of it. We have to consider this, that what it is. Okay, in any way, because there are a lot of conditions we have to tick. We have to actually deal with that. Is it satisfying or not? If it is not satisfying, then we'll not use the particular algorithm. Okay, and we have to actually check the algorithm also, that is it satisfying with our data or not. Okay, now we got our algorithm. Okay, now we have chosen our algorithm. Now, sorry, now we have to deal with its evaluation, because it is not just about choosing algorithm. It is, we have also to check the how its performance is, and based on performance we have to evaluate it. Okay, now as I've told you, we use the cross validation to use like k-fold certified and LLOCV, or leave one out, cross validation, to uh, not miss any sample. Okay, any sample from the data set to get trained with it. Okay, now after choosing algorithm we have to evaluate, and for evaluation what we do is that we use grid search and cross validation. Okay, so using grid search, we find the perfect parameters for it. Okay, what are the parameters? What are the like perfect combination of parameters uh, which is giving the best result? Okay, and using the cross validation, we deal with every single sample of it. Okay, and after using every sample of it, we move ahead. Okay, we move ahead. Now we're done with the training the, and testing the model. Sorry, we're done with the training. We're done with the evaluation of the model. Now we will predict and we'll check our model whether it is performing well or not. Okay, using the cross validation. Okay, using the cross validation. Now moving to next, what we have to do is that we have to make a pipeline. Okay, pipelines. Okay, so what are pipelines actually? So pipelines are nothing but just a process, just step by step processes that makes our life easier. That makes our life easier. How? So in the pipeline, what we have is that we have steps. We have uh, we have steps, like as we have done that we dealt with the data. Okay, we use extraction. Okay, we used pre-processing, then we use training. Okay, now we did that individually. Okay, we did every step in individually. Okay, now what we have to do is that we will not only have just one training uh, it is not that we have training just once. We have to train every time. Okay, as we will get the more data, we'll have to train it every time, so it will be very hectic and cumbersome to train like every time and doing every step uh, again and again. Okay, so okay, so in the pipeline, what you do is that we use just one code. We use one code and it does all the processes. Okay, like dealing with the data, training with the model, evaluation, and getting the perfect score. Okay, to get that, we uh, achieve this by using pipelines. Okay, now we are almost done with our project, as we have dealt with the data. Okay, we used real-time data, we did all the processes, we trained the model. Okay, we used evaluation. Okay, cross validation, grid search, and build the pipeline. Now one most important thing is that choosing the right evaluation metric. Okay, it is very important. Choosing the right evaluation metric, it is very important to get the actual result. Okay, so if is it classification, then we'll use F1 score. Okay, or if it is regression, we'll use R2 score. Okay, it is that simple. Now mostly we have done with the project, as we are done with our training. Okay, training, evaluation. Okay, and we have actually using you predicted and evaluated our model, and we have actually automated our process using the pipelines, which does the every steps in just few codes. Okay, will not have much hectic life for doing every steps every time individually. Okay, we have steps. Now we are actually predicting and we are actually performing very well. Okay, but the problem is that the model is ready, but we do not have something to show, because even if we have built the model, we need an interface. Okay, we need a interface to deal with the people. Okay, who will write their input or query. Okay, or something, and in our model, the model that we have made will give us the output as we have trained it. Okay, we do not have interface, so we have to make it. Okay, now if I tell you that the thing that we have done is, it is just 30 or 40% of our machine learning project, because we have only trained our model. Now we want our model in the front of the people, we want our model to every person who in the world can use it. Okay, we want to make it public, we want to make it easy for the people. Okay, so we need interface, and what we do is that we use REST APIs. Okay, or like something like Streamlit. Okay, Streamlit for the front end. Okay, this is not what we every time we use, but it is a way, it is a tool which we use. Okay, and REST API like Fast API, we use it for backend. Okay, we use it for backend. Now this is the thing for front end, the back end. We can also use web app. Okay, we can have a website, we can have an app also. Okay, to use this. Okay, now as we are moving from building our model to getting into the production. Okay, so from prototype to production. Okay, what it actually matters or says. See, we have a static prototype of model. Okay, but now we want to move it to the production, where it can actually be accessible to the whole world, whole universe, even God can use it. Okay, we want it, and how we do this, it is actually very important, because when we go from production to prototype, reliability, predictability, runtime, memory requirements comes to actually matters. Okay, this comes to the play, it comes to the game and make our life very difficult, because this is something we have to control, this is something we have to actually deal with it. Okay, now in the production, okay, we're not just using sklearn or Python. In the production we have to deal with Python, because we're working as a team. Python, R, C++, Scala, Java. Okay, or it could or Go. Okay, or JavaScript. Okay, because we are actually building a whole set of a whole set of product for the public or for the god or for the universe. Okay, for the universe. And it is not that we that usually what we use as skeleton, it is not we it is used here, it is, but it is not the only thing that is used. And if I talk more about like libraries, then like mllib. Okay, mllib is a library that is used like we use skeleton. Okay, now as we are moving to the production, we will have huge large, make it more larger data sets. Okay, we will dealing with the larger data sets with hundreds of GB. Okay, hundreds of GB, and for dealing with this kind of data, we need lot of RAM. And for something like someone like us, we are not able to afford this because it is not that feasible. Okay, it is not that feasible because every training costs dollar to dollar. Okay, it is not something easy. Okay, now for us it is stored, like as we build the project, it is stored in the numpy array. Okay, numpy array, but it when we have like 100 GB of data, it is not someone like array. It is not something like array. It is a lot. Okay, now for that we need different ways that we can train our model. Okay, now for training our model, there are some ways like out of core learning. Okay, out of core learning. So in the out of core learning, what it is done is that we use only a single computer. Okay, if I make a computer like this, okay, wait, I really make beautiful computer. Yeah, so we have really one computer connected where we are training our model, but we have the data set splitted. Okay, we do not have in this main memory of it. Okay, we have the data set splitted in different memories, but we are training just using one in the one place. Okay, and the second way is parallelization. Okay, parallelization. Okay, if I sorry if I pronounce it wrong, over a cluster. Okay, this is the second way. Okay, so in this, what we do is that now, so what we do actually that in the out of core learning, we used single computer and different memories to store the data and train the model. But here in the parallelization over a cluster, what we use is that we use different computers, different memories to train the model. Okay, splitting every splitting the data here. Okay, and then training at once. Okay, each and every one is training, and then we'll get its output. Okay, so at once we are using this, that is why it is parallel, because at a time we are using different CPUs and different computers and memories to train the model. Okay, that is the thing. And this kind of thing, okay, this computation, this type of computation often require relatively like complex infrastructures, and one of the like most popular and like known tool we can use is Spark, Apache Spark. Okay, or Apache Spark, which is built on Hadoop. Okay, which is actually built for handling these kind of data. Okay, now we're done with our large data set. Okay, now we are done with larger data sets. Okay, now we have to just do some things: train, deploy and monitor. Train, deploy and monitor. We have to train our model, then deploy our model, and then monitor our model, then again train the model. Okay, as we have trained the model, then we have to deploy, then we have to monitor, and seeing any kind of issues or something, then we have to retrain the model. Okay, now we have to train our model, we have trained our model, we have to deploy, and we have a lot of things to do. Now the next step is that into the production we need to use some tools, okay, like ML flow, which tracks the experiments, okay, or the evaluation thing and matrices, okay, of the model. Like every time we train our model, we need to check, we need to keep the data with us, that at what time what happened, okay, which is very important. Okay, we have to track our data, we have to track our experiments as we have done, and we have to go and check the data of it which has been stored, that at what time which model was good and using which combination the model became very good. Okay, then we need to use DVC to actually which is data version control, which is actually very helpful to which is very helpful to take the version for using the different versions of data to track the versions of the data. Okay, because we will not have just one data at once, we will have more data as we go into the real life, okay, into the public. Now moving ahead, then we have Airflow, which is an orchestration tool which runs the model every week or the time period as we decide. So we do not have to train it particularly by our own, which will help us more. Then we use Docker to actually containerize all of it, okay, containerize all of it, so that can so that the work can be done at one system. Okay, then we need AWS or Azure or GCP to deploy it on the cloud, okay, to deploy it on the cloud so that it can be accessible to the most of the people. Okay, like it is obvious that we have to make it accessible. Okay, then we need database, okay, like MySQL or any kind of data set which is used in the company, okay, or whatever corporation as they need. Okay, that is the thing. And like Git also, so Git also to version control. Why? Because after doing all this, okay, suppose there is a team, okay, there is a team of people, like this is person 1, this is person 2, okay, this is also person 2, okay, and this is also, this is me by the way, okay, this is Rishabh, and this is someone, okay, this is she is Angelina, she is Emma, and she is Megan. Okay, these are the people working on a project, okay, now we have to contribute to the same project, but I am working on a different code of my own, Angelina working on a different code, Emma working on a different code, and Megan working on a different code, okay, and we have to contribute to it, okay, and before contributing to it we have a condition, okay, we have a condition is that the evaluation thing or something, that we have to meet the condition so that it can be contributed, okay, because we just cannot actually make any poor prediction or something and we can contribute to the actual main tree, okay, which can go into the production, cause problem. So yeah, this is a condition. And the very last thing that I want to talk is that for the evaluation of these uh, thing evaluation for this thing, we use something called as A/B testing. Okay, A/B testing, A/B testing, and in the evaluation we have two things: online and offline. Okay, so what offline is that we have seen is that we actually do it by our own in our machine. Okay, we actually evaluate the model using the some using the some what we can say some strategies. Okay, like not strategy specifically, I'm not getting the word, but cross validation, grid search, and a lot of evaluation matrices and steps and processes. And one is online. Okay, online, what we are talking about, A/B testing. Okay, so in the A/B testing, what is done is that there are two algorithms are trained, like algo 1, okay, and algo 2, and on algo 1 and algo 2, because we have traffic to our site, we choose two group of people. Okay, and these two group of people, we show them the result of algorithm 1, and we show this group result of algorithm 2, and then we compare both result, that in which algorithm and which group of people we got the better result, and as we have got good result, we use that model. Okay, so that is something we use or used in the evaluation of the project. Okay, and I want to tell you, this is not something that is 100% true. It is something that used in the production. Okay, and you can use this. Okay, but it is very important, and just do not use the 5 line of codes to make a project. Okay.